All right, we're gonna get started. So, welcome to the afternoon session where your bellies are full. You're kind of sleepy, I know, because I'm sleepy. And let me tell you, I have a great voice for putting people to sleep. So, either you're gonna learn something new in this presentation, or you're gonna have a really great nap. Either way, it's a win-win for both of us. My name is Cameron Ayub, and I'm here to talk about designing a flexible UI architecture with special guests, React and GraphQL. And as you can probably tell by the smaller font size, they are not the focal point of this presentation. They're going to be featured. I'm going to talk about them. You'll see some snippets, but this is more of a design and architecture talk. Let me lay out a problem for you. Does your application have really complicated state? Is it kind of hard to debug? Does your client-side code have business rules embedded within it? If any of these things are true, opening up your application might make you die a little bit inside. If that's the case, stick around because in this session I'm going to share with you a three-step approach to making your application a little bit better. The first step we're going to talk about is finding common UI patterns within your application. Then we're going to take those patterns and we're going to codify and formalize them into a schema. Then we're going to drive our UI from that schema. Okay, what do I mean? So I'm going to call this pattern a schema-driven UI. I don't know if that's a real name. That's what I'm going to call this pattern. But basically, a schema-driven UI handles business rules, calculating business rules, providing rendering hints to the UI, as well as validation hints. And it also codifies and formalizes different semantics within your UI. So let's get into it. A schema-driven UI provides a declarative UI that separates rendering logic from business logic. Okay, so the whole talk is going to be about what exactly this means. But the key word there is declarative. We're making a declarative UI. So to understand why we built and needed a schema-driven UI, it probably helps to understand where I'm coming from. So I work for a small town company you probably never heard of. And I get excited about games because I'm a gamer. And on our website, our very small website, we sell games as well as millions of other items. But this information, like product title, price, information here and there, images, that data needs to be managed somewhere. So we have a system that manages all this data. If you scroll down on the page, you're going to see stuff like this. You're going to see item data, which is what we call it. We're very clever, very original. And there are a whole bunch of different things we call attributes. So they're properties of products. So you got stuff for a video game like what platform is it from, what's its ESRB rating, looks like it's pending, who knows, Pokemon could be a mature game, you never know. And what day it comes out. So November 15th, that's why I'm excited about it. It comes out next month. But this data can be really complex. So we sell video games, but we also sell t-shirts, Game of Thrones fans. Not very exciting last season, I have to say. But we sell shirts if you're into them. But there's all sorts of other information. We know that shirts have different sizes. Video games don't really come in sizes, do they? You can't get an extra large video game, although that might be the digital deluxe edition or whatever. But we know that these items are in different stocks. So we know that the medium one is out of stock, but the small one's in stock. And there's a whole bunch of other information that we collect about that. Stuff that is not related to video games. What material is our video game made out of? I don't know, silicon, metal, something. How long is our t-shirt? You don't collect that information for video games. So this data is complex. And behind the scenes, each of these sizes is actually unique items. We just consolidate that for you when we display it to you. Okay, well we had this system that managed all this metadata. And it's a system that I worked on last year. So the best way to explain it is to show you. So we have this UI, and I built this UI myself. It's not the actual UI that we're using. So we have this UI. The way that it's laid out, we have our product title, which is an attribute. So these rows represent attributes of data. I have my value, so Pokemon Sword is the product title for this product. Street date is another attribute that we care about for most items. When does it come out? So in this case, November 15th, pretty straightforward. And we have some other data like what genres is this game, okay? So we're showing this multi-select control here. Now one interesting thing about our UI is at Target we manage lots of different items. And when we're managing data for items, we're not just managing one thing at a time. Can you imagine managing like all 6 or 7 t-shirt sizes all individually? No. So what we do is we offer this editing mode called a bulk editing mode. And so if I come in here as a user and I expand this, I'm going to see all the different items that I'm managing. And this is managing 3 items. So these might be the 3 editions of Pokemon Sword. These are not real. I just made these up. But it showcases one of our UX patterns, which is to be able to manage multiple things at once. But it gets a little bit more complicated because there's business rules behind all of these attributes. So let's say that I come in as a role, like I'm a Nintendo representative. Well, a Nintendo rep is who we call like a vendor. They're an external user from outside Target. Well, they're not going to be allowed to edit certain data. So we need to switch off certain attributes. And so all that logic was in the UI. It wasn't coming from the API. So it was getting hairy. Even more hairy was this idea that not all items are the same, and not all items have the same business rules. So if I could just come in and I could edit both a t-shirt and a video game at once. There's no restrictions on that, which means that business rules that run against video games may not run against t-shirts, and our UI had to handle that. And guess what? A lot of that business logic was inside the UI. Okay. As you can tell, I don't like that. I don't like it one bit. So there were a lot of challenges with this UI, and we had a system that did this. That UX that you saw, we had a system that could do that. It could do that UX. The problem is that it had a bunch of problems. So the first problem is that it had very complex UI state. Now I just showed you 2 behaviors. If something is read-only or not, and whether there's like mixed editability, meaning multiple items could be read-only or not read-only. But there's so many other behaviors that it could do. Imagine trying to have reproduction steps for an error that a user runs into. Like it was almost impossible to debug this thing. And there was no state management solution. We weren't using something like Redux. Then we have business rules. And because we got data from the API, all the business rules were in the client-side code. It was an AngularJS application. Oh my God, nightmare. Then we had to support these 2 different editing modes. So I come in and I want to manage maybe 200 items. 200 items at once. Well, the application would just fall over because it was making thousands of network requests to all of our different microservices to get all this information, and the app would just crash. Just was not able to handle it. So it could scale to about 10 items. You can manage about 10 items at once. So we actually had to implement logic. In order to get into this application, we restricted the amount of items that you could edit. So as you can imagine, our PO was not very happy about this. This has been running for a year, and we had been running in a pilot program. So these are all learnings that came out of that. So we tried to get it to work. It didn't. And we told our PO, hey, we got to rewrite this. And we said it in a sad way, but inside we were like, yes, thank God we can rewrite this thing. Okay, have any of you heard of the term wicked problem? Nobody. Okay. Well, one of my favorite books on programming and software design is Code Complete by Steve McConnell. And in it, he describes the concept of a wicked problem. A wicked problem is a problem that you need to solve once in order to understand it, and then you can solve it again knowing what you know. Software is a wicked problem because we come up with all these requirements, but we don't know what we're building until we build it, and then new requirements come out and we finally understand what we're building, then we can build it again and it's better next time. So that's why software rewrites are just a natural part of the process. They're just organic because you're not going to know what you build until you build it. Okay. That's what we had to do. We had to press the reset button on this UI. So we're pressing the reset button, we get to design it, green field. We knew that we had to change the way we thought about this application because the current one just wasn't scaling. So that brings me to the 3-step process. So the first step is to find common UI patterns. So think about your guys' applications that you work on. Before writing any code, we came together as both the UX team, product owners, and engineers, and we got into the same room. Okay, that's step one. Everybody get into the same room, start talking about what you actually want to build. Now, luckily, we had an application that was built, so we could use hindsight. We could look at the UX patterns that we wanted to do. So this took the form of Adobe InDesign wireframes that our UX designer put together. You could also use Sketch. Sketch is another popular UX software. And I used Adobe XD to make these little samples. It's so easy. I learned it in about 20 minutes. Anyone can use Adobe XD. Just have to have an Adobe subscription. So we got into this room and we started talking about, here's how we want our UX to look, and we came up with our final UX. And this was the final UX. So let's walk through it. Let's walk through an exercise of what do I mean when I say find common UI patterns. So the first step is identify, start from the top down here. So we got these 3 rows of data. And like I said before, each one represents an attribute, an item attribute. Okay, so we could probably represent that as an array of 3 things. We're not sure what they are yet. They're attributes, but we don't know what's on them yet. Then moving left to right, we have this label on the left side. Well, this turns out is an attribute display name. So this is already something right away that the APIs were not returning to us. So this was all hard-coded in the UI. So if I want to show product title, I know what the ID is. It's product_title. That's what it is in the database. That's how I can request it from an API. But I don't get information like, what is the human-friendly name for this? Okay, so we'll add that onto each of our rows. Then we have the middle part, which is what we're actually rendering, what component we're rendering. So you can probably see that there are at least 3 different component types on here. We have a text box, we have a date picker, which kind of looks like a text box, but it's a date picker. And then we have our multi-select little chip component. We're rendering a list of values. So those are all 3 different things. We could probably just put them under an enumeration called a component type. Okay, so now we have these 3 properties, and now we're starting to get closer to understanding how our UI is actually put together. Then we dive a little bit deeper, and we start asking questions. Okay, so for a text box, what do we care? From a UI perspective, what do we care about a text box? Well, we probably care about a min and max length. Okay, so maybe we should add some properties there. For a date, we care about min and max date. Can a user enter a date in the past? Yes or no? Okay, well, we probably need to put a min date and a max date on there. What about the number of values? Can a user put in 99 values or 1,000 values? Well, probably not. There's probably a minimum and a maximum there. So these are all business rules that we need to represent to our UI. So we'll start documenting them. Now, how did we actually document these? Well, we did this. We put them all into JSON documents and we stored them in Git. So we had a Git repository, and we had files in the Git repository, name whatever the attribute is, like product title.json, and they just followed the same contract. Now, what's interesting about this is that it allowed our product owners and our UX designers to participate in this process. So they could update these JSON files without us having to do anything as developers. So here we had product owners and UX designers submitting pull requests to our Git repo. And trust me, they can be taught how to do it, and they enjoy doing it. So what we allowed them to do was have this like generic notes section where they could just write like random business rules. So one random business rule might be, for product title, we're not going to allow it to be editable by a vendor role. For another one, for street date, maybe you can't put a street date in the past. So if it comes from the database and it's in the past, that's okay. But a new value cannot be in the past. Okay, we want to make sure that we note those down. So why do we do that? One reason was because we could have structured metadata. So by keeping this information and documenting it in JSON, we could then ingest it using tools. And that's going to come into play later. And by including those human readable notes, we could record all these little gotchas. So as an engineering team, this was really useful because it allowed us to start thinking about what the future would hold. So how do we translate stuff like this, like these random business rules? This is also where we needed to find patterns. So one pattern might be, we need a way to represent to the UI that something is editable or not editable. Well, that probably is going to be represented by a flag. So it might just be a read-only flag. And then what we started to have our product owners and UX designers do is just input these rules in this format. So they would just say, for this role, this field flips to true or flips to false. And they would just do it in plain English, but we as developers could plan ahead and know that, okay, when I'm implementing this text component, it's going to need to know that it can be required or not required. This type of thinking, starting from the UX and moving upwards, was like a radical shift for the team, because our teams were used to thinking in a top-down approach. As developers, we like to look at APIs and use the APIs to dictate what should be rendered in our UIs. But this was a different type of model. We flipped that on its head. So we started to look at the UX side and think about, here's what the API needs to give us. And one thing our manager kept repeating in these meetings was that the front end is the customer of the back end, meaning we will tell you what we need, don't tell us. So the UX and the UI is the customer of the back end. Traditionally, we might look at it like this, where we have this item, and it's something in our domain. It's an aggregate object. There are properties like product title and street date. And of course, if you requested that from an API, which we were doing, you get something like this back. You get your attributes as properties, and you get the values. Okay, well, the problem with that it is looking at the problem from a consumer's perspective. This is great if we're going to render it on target.com, because you guys, as people, do not care about all the metadata associated with all these attributes. This is the wrong way to think about a master item system. So let me ask you something. How do we describe data in traditional databases? Well, we use a schema. Woo! This probably makes some of you shudder. I mean, we're looking at relational databases. They have tables. The tables have relationships between each other. Each of the columns tell you what type of thing they are. They all have rules like a min length and a max length. And stuff is required and not required. So like, that gives me an idea. What if we just used that same thinking, that same pattern, and just applied it to our UI? So that's what we came up with when we were talking about formalizing this schema. So schema is the declarative contract that's going to render our UI. So we've done all this work. We've documented our UI patterns. We put them in structured JSON. Now we're going to meet as a team and decide, here's the contract that we want in our API that's going to tell the UI how to render. So that's formalizing into a schema. So we're not just going to have values coming back. We're also going to have metadata, like the business rules and the display hints, stuff like help text and description and stuff. So what you end up with is something like this, which should look very familiar to our documentation. It's a little hard to read on this slide, but that's okay. I'm highlighting it. So we have familiar stuff like the ID of the attribute. Okay, it's a dictionary. Key is the ID. And we have another familiar item that I showed before, the display name of what we want to display. But then we might have something like a description. Turns out, when you have employees who are inputting this data, they need to know what it is. Not everybody can keep everything in their head. So we might need to include some information about like, what is this attribute? Can you explain it in business terms? And then we have stuff like the rules I talked about. And we might put them under a separate property just to keep it organized. So we got our default rules. These are the rules by default of how an attribute behaves. So it's required, there's a mid-length, there's a max length. It's not read-only, you can edit it. But then we have display hints, and then we have item attributes, or item values. So one interesting thing is in our traditional API, we're just giving you the raw values, and then it's up to the client side to format those. Well, that's not going to scale very well with hundreds of attributes, which is what we're dealing with, even sometimes thousands of attributes. So we need a way to represent both the raw values and the human readable values. So our values are going to be something that's kind of an aggregate of both of them. So for a text field, they're probably going to be the same value, Pokemon Sword, Pokemon Sword. But for something like street date, let's see if I can highlight it. For street day, it's going to be something different. So the raw value might be a timestamp, might be the UTC timestamp, but the human readable value is going to be formatted. And we don't want the client to determine how to format that. Of course they can, they got the raw value, so you can override it if you want to, but we want to provide a human readable value when we're outputting read-only information. So we need these two values. Okay, so this is what our schema is going to end up looking like. And notice too, I have this field called override rules. So this is where we're getting into managing multiple items at once, where some of the items might have different business rules than the other ones in the collection that you're editing. So by using this idea of default rules and then override rules, the UI can know, okay, for this item I'm going to render it as editable, or I'm going to render it as required, and this other item I'm not going to. So that's how we can pass that information down. Great. So I just showed you the end result. We have these building blocks. We've designed our schema, but like, how do we go from A to Z? How do we go from raw data from a database or external APIs and get that into the schema format? So that's the meat and potatoes step, which is to drive the UI from the schema. The high-level architecture goes something like this. In our case, we have this front end, which is written in React, special guest, appearance, React. And then we have our GraphQL backend. So the React front end has two major parts to it. We have our state management. This simplifies a lot of that complex UI state interaction. So we're using Redux in this case. And then we have the client-side rule engine. So what implements the requiredness, the min, max, length, all that kind of stuff. Our client-side rule engine can implement that generically for all the attributes. And then we move up, how do we actually build the schema? So this is the workhorse of this whole system. This takes data from multiple sources, like we have our primary data source, might be a SQL database, in our case it was, and maybe external APIs. Where do I get those human readable values? Well, we're the master item data system. So that means in a big enterprise, like we just have the raw values in our database, our primary store, and then we have to go to other teams, microservices, to go grab what the human readable values are. So there's like a dozen different microservices we have to go request data from. So this takes care of that. And it does it through this data resolution step and the Schema Engine step. But why GraphQL? Why bother using something like GraphQL when we could use something like REST, perhaps? So we've been talking about schemas. And if you're not familiar with GraphQL, GraphQL is built on the idea of schemas. You define everything as a schema. So you define your types, and your types have types, and they look very much like interfaces in C# or in TypeScript. But the major thing is that GraphQL is a specification. And so like any specification, it provides some nice benefits. And that is predictability. So you know how to call any GraphQL API if you understand the GraphQL spec, which means that you can mix different technologies together. It provides consistency. So the GitHub GraphQL API and our GraphQL API, I know how to query both of them because it's following the spec. And it provides safety, specifically safety in types. So by defining these contracts up front in a schema, in a GraphQL schema, GraphQL can do a whole lot of validation for you that you would have to do otherwise. So if I return an object that doesn't match my GraphQL schema, GraphQL will validate that. And so that was super useful for building this API in parallel with our backend team. So here's what it looks like. We can describe our previous schema contract as GraphQL types. So here's our different component types that we support. And because I'm defining them in a GraphQL schema, they're documented. So I can even add, they're not JS doc, they're doc hints or whatever they call it, but I can add documentation like with Markdown to each of these different fields so people can understand here's what's in my API. And we have the different display information, like maybe I have the component type here, might have the help text or something like that, and I got my ID in my display. So these are all portions of our GraphQL schema, and you define them in a language that is very similar to like C# or TypeScript, but it's GraphQL. Now the QL stands for query language. So the types are part of the graph system. You define your types in a graph. They can be related to each other, like I'm I'm relating these here. But then we have your query language. So you can issue queries, and your queries follow a standard spec. So queries start with the name of the query, and they can have arguments. So I can pass different arguments to my query. Okay, so this is already something pretty different than REST. REST, I usually can just pass in a single ID and then maybe a query string of random things that the developer has decided they'll accept. Or actually, wait, it's probably a post. Oh no, wait, it's a put. No, hold on. Delete, I think, for this one. Okay, so anyway, for GraphQL, it's a single thing. You just issue a query, and it's all documented, and you can pass in these arguments at different levels of your query. So this format here is a shape, and this shape is what gets returned back to you, exactly. So this is the shape of the JSON that's going to be returned. So I know exactly what I'm getting, and I'm only requesting what I care about. If I don't care about the human value, I can just leave it out. The other thing that you can do as a client is you can alias different fields. So if I don't like the field description, I can just rename it, and it'll come back as title if I want to do that. I can include directives. So this @ denotes a directive. This is custom logic that you can implement on your queries. You can do whatever you want them to do. In this case, this is built into the Apollo server is what we were using. This says include this property if this hydrate argument is true. Otherwise, it'll skip the processing of this. So if you have something expensive that uses a lot of network latency, you can just skip it. If you want to, you can implement a directive to do that. The other thing that's built in, you can kind of see down here, is batch querying. So item metadata and attributes are two separate queries in GraphQL, and I can request them both at once in a single batch. So it just has batch built in. There are a lot of other benefits. One great thing is that you can have a single version for your API, which is what we all end up doing anyways. It's always V1, right? So anytime you release a new version of your API, it's always V1 because it's too hard to change it to V2. But with GraphQL, you can just avoid that entirely. You just have your one endpoint, one version. The reason that you can do that is because GraphQL isolates all these different fields, which means that as a client, I have to include what I want. So if I have item ID, I'm not going to get read-only or required. It's just not going to send it to me, which means that GraphQL can see what people are querying. And if it can see what people are querying, it can tell you what people are querying, and then you know, well, this application is not using item ID. We can just delete it. We can safely delete it because nobody's querying it. Or maybe they are, and you want to implement a directive that will just warn them. So in the response back from GraphQL, maybe your directive implements logic that says, hey, use max length instead. And so developers know, okay, well, maybe I should switch to this other field. So the field level analytics that you can get with GraphQL is pretty awesome. The other nice feature is subscriptions. So with subscriptions, think about hooking up to something like Firebase, like a real-time database, or I like RavenDB, and RavenDB has document subscriptions. So if I update an item and I want to notify 100 clients that that item got updated, I might use something like Firebase or RavenDB. And through GraphQL, you can subscribe to queries. And so when GraphQL detects that something got updated, it can push those updates down to the client using Socket.io or WebSockets or what have you. SignalR if you're .NET Core. There are a bunch of other benefits to using GraphQL. We're not going to go into too much depth, but depending on what server you're using, you can sometimes get caching built in. So you get caching infrastructure. Like I said, you can get field level timing and analytics. Some of these companies like Apollo have a cloud product you can hook up to, and it gives you all sorts of performance metrics and instrumentation. You can implement custom directives, so we use it for things like authentication. If you want to permission different parts of your query, you can do that with directives. It also provides an extensible architecture, so you can write your own middleware. So think about just the request pipeline. It allows you to add steps in between that pipeline where you can do logging or error reporting or things like that. But if you want to use REST, go ahead. So there's no dogma here. I mean, we're actually calling a bunch of REST APIs. All the microservices that we call, they're all REST APIs. We just want to aggregate them under one endpoint, and GraphQL is very good at doing that. We also really benefited from that consistency and safety. So imagine you're writing this API, in GraphQL, and you have this other team next to you, which is in our case, they're writing a Java backend, and they're pushing updates to their API. And of course, it's one version, right, /v1. So if they make a mistake in their contract, GraphQL is going to catch it. So we're going to get alerts right away that, hey, something is wrong from this backend API because it doesn't match this contract. GraphQL is going to catch that. So what we can do is we can write functional tests that go against our GraphQL API, make sure that all the other APIs we're calling all match our contracts. So that was a huge win for us. But nothing says you can't use REST either. Okay, so back to how this data gets resolved. So we issue a GraphQL query. And I just showed you what a GraphQL query looks like. This is the shape of the request and the response that we get. And this should look very familiar because this is our schema contract that we documented and we formalized. And we can represent in a GraphQL schema, which means that we can request it in a GraphQL query. There's just some other things that we can do now. So if I want item data, I can pass in these arguments that tells me, okay, go grab the genres attribute. And for the genres attribute, go get me the raw values for these items. And then go get me the human value too. So the way that this process works is it maps these attributes using some internal dictionary. It resolves this data from all the different data sources, and that can be dependent on a per attribute basis, and loads it all up. So imagine something like this. The request comes in for the genres attribute, and you have something like this little resolver. So we can export a JavaScript module that represents our attribute, and it can export a contract of functions that we can call. One of them might be like fetch data. So GraphQL, JavaScript, Node doesn't really have the idea of like dependency injection per se, but in GraphQL you always get past a context. This context can have whatever you need to put on it, so you can do service objects, authenticated user information, anything you want. So let's say that I know from the arguments I give my item IDs that I want to grab, I give my services that I've created. One of those services maybe is a database, maybe our Postgres database. And that has our repository, so we go get items. And then we return the data in this format where we have our item ID and our raw value. Now remember I said one of the benefits of GraphQL is this consistency. So if I don't return the data in this format, GraphQL will throw an exception. So it'll make sure that we're consistent with the way that we return data. Now this data resolution seems simple at first, but gets complicated quickly. So if I am requesting data for genres, for example, yes, that primary data might come from our Postgres database, so I issue a SQL query. But then if the user and the UI needs the human readable value, like I said, that's from a different microservice. So then we got to do another async call to go get what do 1 and 3 resolve to? Well, adventure, role-playing game, those are the human values that we need to get. So the problem with this is that if I'm asking for multiple things in a single request, well, you can imagine that we're going to be doing a lot of duplicate service calls, because if I'm isolating each of the attributes separately, they're all going to call the database with the same query. Well, there's going to be duplicate data, and I don't want to do that. So we can use something like Data Loader, which is a Facebook package. All it is just a per request cache. So it knows based on the key that I've already fetched this data, I'm going to just return you the object in the cache. So this would be like in C# you create like a scoped, in request scope type of object, or like Entity Framework does this all for you. If you request the same entity with the same ID, it gives you it from cache. So in Node.js you can do something similar. There's even a data loader package for Java. Java is your thing. So that's the per request cache, but we also need cross request caching. Because if I'm going to go get all these different types of attributes, and they're going to come from a dozen microservices, well, suddenly all these performance benefits I've been talking about go down the drain. Because if a single GraphQL request results in a dozen microservice requests, then it's going to be as slow as the slowest microservice request, right? So we can introduce a caching layer. And this is one of the nice benefits of using something like Apollo GraphQL Engine, is it just has a plug-and-play caching system. So in our case, we can use Memcache or Redis, so we use Redis. And then each of these services can have their own time to live. So we can update those asynchronously. Maybe at your organization you have a message-based architecture. So then you can subscribe to like Kafka topics or Azure Event Bus or whatever you need to know like when you should refresh data. Because it's human readable values and not the raw values, we're not too worried about cache staleness. We care about speed. Then we have the actual schema engine. So now I've grabbed my data from these various data sources, and now I need to actually return it in this schema format. So we have our base schema, which comes from our documentation, and we add our values on top of it. So this base schema, where does it come from? Well, remember that we documented all this stuff in structured JSON in a Git repository, which means that we can take the JSON that we stored in Git and we can push it to something like a document database, like MongoDB, because MongoDB stores documents as JSON. So literally, I can just lift the documents out of Git, shove them into MongoDB, and we can create automation that will just automatically do that anytime there's changes. So this means that updates to our UI, if you think about it, can flow directly from pull requests to our original repository, which means that product owners, UX designers, if there's a change in how the business rules work, they can get their changes flowing all the way down to our UI with no work from us. So this is one of the benefits of using structured documentation. Okay, so we take this base schema, but then we got to do stuff to it. We have to run business rules. So like what? Well, we have our default rules like something is required and it's not editable. But now within the context of our schema engine, during a request, we've authenticated the user. We have all the authentication information. We know that maybe they're part of this vendor role. They're a Nintendo representative logging in. So now we can tweak the rules. So rather than keeping the override rules as null, now we can just tweak the different default rules and flip those. So for this item, we know that a Nintendo representative can't edit it. So it's not required because they can't edit it, so we don't want to throw an error if they don't enter it, but it's read-only, so we're going to render it read-only. That's what the rule engine does. So this was key, because remember at the beginning I said the business rules were all embedded within the client-side application. So this lifts it up out of the client because the client should not be the ones as the source of truth for how business rules get determined. The business rules run on the server. They're just represented in simple terms to the client. So take your business rules and distill them down into the actual flags that the UI cares about. So that's the high-level architecture for the back end. Now moving to the front end, our React code. The React code is responsible for several areas. First, it's responsible for actually rendering that schema. Then we needed to support journaling. So a journal is just change tracking. So as the user is changing data in the UI, we need to track that so that we can send those changes back up to the server. It also handles all the behaviors of relationships, which I haven't talked about because they're complex, so we'll cover that. And it also handles that single versus multi-item mode behaviors that I was showing you. So for rendering a schema, it should be pretty straightforward by now. So now you know that when I request data from the server, I'm getting it in the schema format, which means that I really just need a way to take this component type and translate it to some sort of React component. And literally we have something like this in our code base that's just the central factory function that says, give me your component type. If I have a match for it in my dictionary, then I'm going to render that guy, and I'm going to pass consistent props to it. Because we're using TypeScript, we can make a contract for what those props look like, so we make sure it's consistent. So that's pretty straightforward. What do we do for different rules, like whether something's read-only? So we don't render a text box in that case, we just render the value. Well, we delegate that down to the component. Because remember, we have our whole schema available to us, which means that the component has that schema available. So it can get the read-only flag, the raw value, the human value, whatever it needs to, and it can do whatever it needs to do. So for a text box, that's pretty straightforward. It's just rendering the value, except when you have Unicode characters or entities, you got to make sure you handle that. But for something like a multi-select, you're not rendering a select control. You're actually just rendering the chips. So different controls might need different rendering needs. That's why we delegate that down all the way down to the components. Oops. Other rules can also be pretty straightforward. So for text boxes that need like a max length rule, again, that's delegated down to the component. And so we can show a character counter. And a lot of different libraries and frameworks have that kind of stuff built in. But because you have the schema, it's really easy to just have Boolean logic that's like, hey, if I got a max length, I'm going to show this, or I'm going to go down this new code path. The one that's really kind of interesting is this multi-select. So when I'm editing it, it shows me the values that I've selected, but I can also add new values. So we use like a type ahead. So this is using like React select. It's a library. But as soon as I put my cursor on the control, it needs to go fetch what potential values that are valid I can pass in. So maybe you can see where I'm going with this, but because we have this generic schema and we have all the infrastructure available on the server to map all these attributes, we can use that same infrastructure to issue generic queries for any of these type of heads, for any of these attributes. So we might have a lookup query, and we might pass in the attribute that we care about, and it all has a consistent contract, and the options come back in the same format as the schema. So the client side can merge those values together, making it easy to track. Speaking of tracking, we wanted to allow the user to review before saving changes. We also wanted to make it easy for them to quickly enter data. So our users, when we observe them, would quickly tab between different fields. Well, in the old system, we had a system that would dispatch a network request every single time you blurred a field. So if you're going through the form, it's starting to get bogged down, and there was a lot of issues with the UI just being totally janky because business rules were running both on the client and at the enterprise level, and the UI would just get out of sync, and it was a nightmare. So we needed a way to support batch saving, and the way that we did that was through a journaling mechanism. Now, because we're using Redux, Redux works by dispatching actions which change state. But not every action results in a change that we care about. So what we did was we just recorded which actions resulted in a change. And we stored those changes in a basic dictionary, a journal. And so we could track the changes during a session, and when they submitted a save, we could flush the journal, we could allow people to roll back to a previous value. There are a lot of libraries that can help with this, usually called like a history or journal package. So to the user, it was really simple. To the user, it would just say, hey, you change this. But in the back end, in the Redux store, we'd actually be tracking those changes. Now, I've kept things pretty simple so far. Simple. This is pretty complex stuff. But it gets even more complex when we talk about relationships between attributes. So one major relationship is the taxonomy of attributes. So I talked about the idea that we have hundreds and maybe even thousands of these attributes. Well, how do we actually manage that as a user? How do I navigate my UI with hundreds of attributes? So in reality, we have a hierarchy of attributes. So there's a taxonomy. Attributes can exist in a standalone fashion, like I showed you, product title, street date, but they can also be grouped together. So if I have package dimensions, think about the boxes that things get shipped to you in. Well, the only way to calculate that box size is if we know how big an item is. So there might be a width, a height, a depth. That gets used to determine package dimensions. So we might want to render maybe a different UI. So we're not just talking about a single hook like component type. That was the only hook that I talked about today. But we might have group type. So we might render something totally different in that section. And we even have the concept of like an editor, which is like a pane. So if I have a two-pane application and I might just want to customize the entire right side of the screen, we can have an editor type attribute. And we use the same basic formula where there's a factory function. It checks to see if this editor exists. If it does, render this editor. Otherwise, render the default editor. And it all works because we have a consistent schema. So as long as the inputs and the outputs are the same, they match the schema contract, we can do lots of really awesome custom UI. There are a bunch of other relationships we had to deal with. One of them was a blocking relationship. So the idea here is that you update one field and another one becomes blocked out. You can't change it. And this we could express statically. And this is also where those business notes come into play. Because let's say that you update title and users are not supposed to update genre afterwards because there's complex business rules happening and being calculated. So we introduced the idea of a blocking relationship. So the UI has to handle that. Not only do we have these list of values type of attributes, but in a lot of cases, we need to know what the primary value is. Well, the values in this dropdown are powered by this, right? So the UI has to handle that. And then there's conditional relationships. Maybe some new attributes pop up after you enter a specific value for one of the other attributes. And we literally had a portion of the UI that dealt with thousands of these because there was a huge tree and graph of questions. So graph theory and math came in handy for that. That was fun. No, it wasn't. It was not fun. So representing these in the schema is pretty straightforward. I mean, they can be pretty static. The most interesting one is probably the conditional stuff. We had to build this dynamically. So it could come down from the server. The server could fill in what values would match, what the matching algorithm was. Is it some of the values? Is it every value, etc. The last thing that the UI needed to handle was multi-items. So this involved mixed editability, variedness, and payload size. Mixed editability is something I showed you already, where some of the items are editable, some are not. We need to do different behavior based on that. And we have variedness, which is everything is editable, but all the values are different. So how do we handle that? If you edit here at the top, what do I cascade down into the items? Well, you have to respect whether things are editable, whether or not. What rules do you run? You have to run the requiredness rule. This might have a different max length than this one. You have to respect all those different rules. Finally, payload size. Remember I said that we had to scale to like 200 items at once. Well, making a single edit to 200 things can result in a very big JSON diff, right? So there was a lot of optimizations we had to do to make sure we consolidated that. We tried to compress the information we would send back up to the server. Speaking of sending back up to the server, we've only been talking about how to actually render information, but how do we actually get information back up to the server? Well, luckily, we can reuse almost all the same infrastructure. So remember I talked about journaling. Well, we have our journal entries. We just grab the last one for each of the attributes, for each of the items, and we can send that back up to the server, and it can follow the same pattern. It can go fetch the original data, and it can receive the new data from the client. It can compare those, validate those using the same exact schema and rule engine we're using, and then it can persist the data and publish those changes. So the publishing changes can be asynchronous. The client can poll for new changes. You could subscribe using GraphQL or a real-time database. To the user, this is pretty simple. It looks pretty simple to a user, and that's good. That's on purpose. When they save something, we can show an indicator because we know which attributes we're saving. When it's successful, we can surface that. But we could choose not to do any of that. We could just surface errors. If we wanted an exception-based experience, then we just assume that everything works. So we can be optimistic. So as soon as the user hits save, we have enough information using the schema to guess that things are going to work out. And if they don't, that's when we can surface errors. So we can be optimistic. So that was a lot of information, right? And we only had 50 minutes to talk about it. So let me go over it one last time so it sinks in. If you're having problems with the UI and you want to make it flexible, you can follow these 3 steps. First, find your common UI patterns. For us, that meant scouring over UX wireframes, talking about how we actually want the design to work, and going through those exercises and storing them in structured JSON documents. Then you can take those JSON documents and form the basis of a schema. And this might look something totally different for your domain, and I would expect it to. If you're working on a CMS, you might have different types of content types that you care about, that you want to represent in your schema. If you're a finance application, you're making reports. Your reports might have a different type of schema. Whatever it looks like to you, you need to formalize it. Then the fun part is that you get to drive your UI from it. So if you have a lot of repeatable data, a lot of generic data, you can build an engine that will take your structured documentation, run business rules against it, encapsulate those business rules, tweak the schema, and use it to drive your UI. So if this sounds interesting to you, and you're kind of wanting to know, okay, that's great, but where should I start? First, I'm going to just tell you that you should decide whether or not this is something that's going to be useful to you. So I shared my use case, which is a huge metadata system. So if you have something like that, you have a big data entry application that has a lot of similar forms, you have a reporting system that has lots of similar reports, maybe you're trying to build a CMS for some reason. We all like to build CMSs. It has the same sort of architecture, this generic schema-driven architecture. You also don't have to design the schema yourself. So yes, we implemented something custom because that's what worked for our domain, But JSON schema exists, and there are packages that can take a JSON schema and render forms. So one is React JSON schema from Mozilla, and the other one is Angular schema form. So you can check those out. And of course, if none of those work, then you have my permission to roll your own. We have literally like 20 seconds left for questions, if anyone has one question. Yes?
I'm just curious, do you just support multiple languages?
Like localization, internationalization.
Like English, French?
Yeah, so not in our application, but this would allow you to do that.
Okay.
You saw how I had like in my schema like the display name or something like that. Since the server could know, or the client could send up what the user's locale is, like from the browser, then you could just swap those values out. So if you had like a resource dictionary, like in .NET, it's pretty common to have a resource dictionary. You just look up what that attribute translation is, and you could plug that into the schema, which will then render down into the UI. So there's definitely a way to do that. Okay, I know there's some stuff that I did not talk about. If you want to talk about a universal rule engine where you can run both the client and the server business rules on both, we can talk about that later. I didn't really dive into how the state management works with Redux and how the heck we tested this thing. So if you have questions about that, come see me afterwards. I'm just going to go here. If you want that list of resources, I'm using Burke's little URL list. So take a picture of this. Like I said, my name is Kamran Ayub. You can probably guess I work at Target. I also do a lot of side stuff. I have a game engine that I help work on, which is open source. I have a product called Keep Track of My Games. All those links are in here. I also have Pluralsight courses if you're interested in learning about Azure Storage, CDN, or if you like RavenDB, I have a RavenDB course. So I just want to say I appreciate you taking the time to come out and see this presentation. So I hope you learned something. Thank you.